are interested in finding the equation of trajectory for this projectile. That is, when the body has gone from here to here, and let's say we take this as x-axis and we consider this as y-axis, this is origin. So we are interested, if a body is projected with the velocity u making angle theta, that at any instant if it has the values x and y, is there any relationship between this x and y coordinates? And if it is, then what is that relationship? So for that we shall be making use of our basic understanding, that is acceleration along x-axis is equal to 0, acceleration along y-axis is equal to g in the downward direction. In the upward direction, let's take the vectors as positive. In the downward direction, let's take it as negative. Now let's say the body has reached from here O to A. We are now interested in what is Sx. So Sx is the distance or displacement along the x-axis. It is going to be x only. So Sx is equal to ux into t. So this is like this. What is ux? We have broken this into two components. One is u cos theta, the other along the y-axis is u sin theta. So these are two components of this velocity u. U cos theta is a component which is responsible for moving the body along the x-axis, and this u sin theta is responsible for moving the body along the y-axis. So Sx is equal to uxt plus half axt square. We know that is acceleration on the x-axis is equal to 0, so this goes off. Sx, what is Sx when we consider from O to A? The displacement along the x-axis is only x only. So we say x, which is this x only. Ux is u cos theta into t. So this t comes out to be x upon u cos theta. So this is the time which comes out to be t is equal to x upon u cos theta. We shall be making use of it and we shall be substituting in our equation along the y-axis. Now if we consider along the y-axis, if we see along the y-axis what is happening is, we say from here to here the displacement along y-axis is this much only, that is y. We say sy is equal to uyt plus half ayt square. Now let's use this. So what is displacement along the y-axis when the body has gone from O to A? So this y only. It is in the upward direction, so that's why it is positive only. Uy, initial velocity along the y-axis is u sin theta. And what is the time from here to here? Time is a scalar quantity. It doesn't have any direction. It doesn't mean that is this time is only along the x-axis or y-axis. Time is time, scalar quantity, and this from here to here, it had taken the time as x upon u cos theta, so we put it over here. So this is x upon u cos theta plus half ay. Acceleration on the y-axis is g in the downward direction. In the downward direction, we have to take it as negative. So it is minus g into t square. T is once again x upon u cos theta. So this comes out to be y is equal to u get cancelled. Y is equal to x tan theta minus gx square upon 2u square cos square theta, that is a inverted parabola. So over here we see this is a quadratic equation with x square coefficient as negative, so this is going to be inverted parabola. So if at any instant we have to find out what is a coordinate, one coordinate if the other coordinate is known, let's say over here at, suppose this is x is equal to suppose 5 meter. We have to find what is the value of y. So what we shall be doing is, we shall be putting x as 5 and all the values, that is theta at what angle it has been projected, with what velocity it has been projected, x is once again 5, and correspondingly we can get what is the height at which this body will be when the body has moved x is equal to 5 meter in this forward direction. So this is one way how we can use this equation of trajectory.